Hello there, Mr. Munro speaking. This video is going to have a quick look at how to simplify fractions. Now, to simplify fractions, you first need to understand one basic rule, that different fractions can have the same value, but of course only specific fractions. I've got three fractions here: 1/2, 2/4, and 3/6. Now you can see I've tried to draw some circles. They're not necessarily very accurate, but you should be able to get the idea. So 1/2 has of course half the circle coloured in. 2/4, well, whilst there are two sections coloured in, it still has the same size that's been coloured in as the half, because of course 2/4 adds up to a half. The same with here with the 3/6. I've got three parts that have been coloured in, but together they're the same as a half. Now, these fractions are what we would call equivalent. And just to spell it for you, equivalent fractions. Okay, and that's where fractions have the same value. Now we can use that to simplify. Now simplify is where we want to find the smallest possible numbers. It's quite straightforward, this one actually. So my first example, 24/30. Now most people halve a fraction and halve it and halve it and halve it, and there's nothing necessarily wrong with that, but it doesn't work in every case. Dividing something by 2 is essentially dividing it by a prime number. Other prime numbers could be 3, 5, 7, and so on. And I always suggest testing prime numbers. What's important is when you're dividing, you divide both the top and the bottom by the same number. You cannot have decimals in a fraction, so if you would do a division that would end up with a decimal, then of course you can't do it. So for here, my first step, well, why don't I just divide the top and the bottom by 2. Top would become 12, bottom would become 15. Now at this point, I can't divide by 2 again, because if I divide 15 by 2, I get a decimal number, which I can't have. So some people go, oh, I'm done. I can't divide it by 2 anymore, I'm done. Not quite. I mentioned a second ago that I could divide by primes. So here, I've just divided by 2. My next step, I could try dividing by 3, because 12 can be divided by 3, as can 15. 12 divided by 3 is 4, and 15 divided by 3 is 5. So my final answer is 4/5. Now, some people can break it down step by step. Others, if you can see the common factor between them, you can do this in one step, just dividing by 6. It doesn't matter whether you do that way or that way. As long as you get the right answer, everyone's happy. Next, question 2. So, this time I've got 18/39. 39 is a bit of a difficult number. Not many numbers go into it. So I can't divide by 2. Okay. So other numbers, 18 can be divided by 2, by 3, by 6, by 9, and so on. 39, I can't divide it by 2, but I can divide it by 3. We can see that because of course 3 here and 9 here. So 18 divided by 3 is 6. 39 divided by 3 is 13. Now, here's the thing. 13 is a prime number. The only number I can divide 13 by is 1 and 13. Well, dividing by 1 is pointless. Nothing's going to change. And obviously 6 can't be divided by 13, so my answer is done. Next question, and my final example for you. 36/48. So again, why don't we go with the old divide it by 2 trick. Divide them by 2, and I get 18/24. I could technically divide by 2 again, which is going to give me 9/12. Now again, I can't divide by 2 for a third time because 9 is an odd number, but I'm not done because I can divide by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4, which is my final answer. Now just like with example 1, there is a shortcut. 36 and 48 can both be divided by the same number. That number is 12. 36 divided by 12 is 3, 48 divided by 12 is 4, and that would actually get you the same answer. Anyway, practice to be had here. It doesn't necessarily matter if you're comfortable doing it step by step, or you'd rather go for the big division. Just work on your accuracy. Thank you very much.